institutions, was founded during August in 2008 with four branches of engineering. VMTW is an exemplary institute of higher learning with a mission of pursuing excellence in education and research. The institution, with their diverse and dynamic community of about 2,000 students, offers a distinctive combination of some of the finest facilities. Began vision to empower students with professional education using creative, innovative technical practices of global competency and research aptitude to become competitive engineers with ethical values and entrepreneurial skills. Mission to impart a value-based professional education through creative and innovative teaching, learning process to face the global challenges of the new era technology. To inculcate research aptitude and to bring out creativity in students by imparting engineering knowledge, embodying interpersonal skills to promote innovation, research, and entrepreneurship. It's a great opportunity to introduce today's resource person, Dr. J. Kandaswamy. Sir is working as a professor in the Department of Mechanical Engineering, MVSR College, Hyderabad. Is associated with MVSR since 2007. He has 18 years of teaching experience and of 5 years of research experience. He has a passion for research and is keenly interested in conducting independent development and research projects. His papers are published in sci-listed journals. Projects are in progress in the tune of 26 lakhs. And the qualities what the sir has, like inspiring a high-level, disciplined, and hard-working professor with sound knowledge in basics of mechanical science and computer-related applications in mechanical engineering. His areas of interest including metal joining, server plastic deformation process, mathematical modeling of manufacturing process, optimization of parameters. He has organized several workshops in his research areas of interest. And sir completed a PhD from JNTH Hyderabad, Telangana. And the title related with the project is Evaluation Post-Process and Characterization of Friction Stir Welding Dissimilar alloys. So it's a great opportunity to be as a speaker for today. Sir?
Yes, madam. Yeah, can I start? Hello. Hello, can I start?
So can you hear me, sir?
I could hear you, but can you hear me? Can you hear me?
So you're hearing my voice, sir?
Yes, I could hear. Right, hence we will go with the topic. Fine. This is all about research opportunities in powder metallurgy based forming. Myself, Dr. J. Kandaswamy, working as professor in Department of Mechanical Engineering, Maturi Venkata Subbarao Engineering College, Hyderabad. At the outset, I would like to thank Mr. Ishwarrao Bandi, Assistant Professor in Vigyan Institute of Management and Technology for Women, who has initiated the process. And of course, the department and the institute an opportunity to be the key speaker for today's webinar. Yeah, so at the outset, I wish you all a very happy Engineers Day. Lot of quotations will be flowing in our WhatsApps and LinkedIn. Nothing is possible in this world without the engineer. And I wish, because engineer is the one who creates the world how he wants to see it. Hence, happy engineers team. We make the world, we connect the world, we rule the world. Yeah. So the very basic thing is, first we have an idea in our brain. We have an idea in our brain, and later that idea gets converted into a product. In between that, there are so many things. The idea getting converted into a product is what the real magic that an engineer makes. It's once upon a time we think how data can get transferred. Today, GBs and terabytes of data are getting transferred within seconds, milliseconds. That's the beauty of an engineer. So, if once you want to change your idea into any product, then there comes the final resort of enjoying the product comes from manufacturing. You see this materialistic world, it's called as materialistic world participants. This materialistic world is filled with a lot of has to be manufactured to feel it. Hence, manufacturing is the last resort of the idea getting into a product shape, and we touch and feel the product. An idea getting converted, the place is what? If at all a thought is there to make a recipe, it gets manufactured at the kitchen, and you want to taste it, you require a kitchen and you require materials. So in this materialistic world, materials are so powerful. You introduce a new material, the world changes totally. With the invention of polymers, lot of wood components have been thrown away. Lot of steel components are replaced. So that is the part. With the invention of titanium like alloy, the aerospace industry and defense industry has revamped itself in so many spheres. Hence, manufacturing is one of the very fine activity that happens in any industry. So, particularly core manufacturing like mechanical, electrical, electronics. You want an electrical industry, we might have not seen the things around us. If you see, you feel the power of manufacturing. A lot of manufacturing takes place. A lot is involved. Right. Every
Sir,
every
we are
component.
unable to hear your voice, sir.
Every
Sir,
component.
voice.
One second. No, my this is how I have muted. Hello, can you able to hear me? Am I audible?
Yes, sir. Yes,
Am I?
yes, sir. You're audible, sir.
Fine, fine. Okay, then well and good.
Okay, sir.
And maybe see every component has to be manufactured, and there are different several manufacturing methods. And material comes in different forms, and ultimate idea is point of application, environment of application, situation of application, time required for application, everything, and how long it has to perform, the component has to perform, all has to be taken into account, and then it has to be manufactured, the product has to be manufactured. Material come for everything in this world, you require materials, and the material may be in solid form, liquid form, gaseous form, in plasma state, whatever it is, you have different types of materials. You have different types of materials. And then this is what the basic classification of materials. You have metals, alloys, non-metals. You know, the beauty of powder metallurgy is all these material can be made into powder and can be enjoyed. See, if you want to feed a child, everything comes to a semi-solid state. Any food category will either you it is maybe in solid state or liquid state or whatever it is, can be any very hard rock solid food component can also be brought into a semi-solid state like that. Whatever materials I have projected on the screen can be made into powder state, and then it can be processed to harvest the advantages of powder metallurgy. Right. See, NAT is going to deal with this tetrahedron of this materials: performance, structure, properties, and processing. That's the beauty. If any materials engineer or mechanical engineer, anyone has to deal with these four corners: properties, structure, performance, and processing. You know, titanium is very difficult to process. Magnesium is very difficult to, aluminum can be processed very easily. But the performance of the stiffness of magnesium is far higher, stiffness ratio is far higher when compared to aluminum. Hence, we have to balance with these four corners. What a material science engineer has to consider: four entwined concepts. All are interrelated. You have to convince at one particular point and then go for your best. The structure is how composition, phases, structures, all those things are there. Right. And what are the properties? First case. If at all I go over here, you can see the structure like BCC, HCP, all those things, what we know. And then that structure, we have two ways. The way atoms, ion molecules are arranged is called atomic structure. And how the bonding takes place is what electromagnetic structure. So the way the electrons charge are distributed and the spin is associated with electrons are called electromagnetic structure. So all this comes into picture. So what are the properties of materials? If I say these are the properties, atomic structure is one corner of the tetrahedron, electromagnetic structure and atomic structure. And properties, when I see from my mechanical engineering point of view or its application point of view, I see basic mechanical properties, behavior of loading, physical properties, and chemical properties. So these are the basic properties of materials. Right. And then how the crystal varies. An atom joins all these to get the structure. There are two types of structure an engineer has to balance. One is crystal and another one is electromagnetic. Then for thermomechanical treatment, your microstructure changes. And at last, the material which is in microstructure form will be processed with this basic forms: casting, metal forming, welding, powder processing, and machining, and it comes into a component. So all this has to be, and we are much bothered today about powder processing, how I can process, what is the need for processing, all these things we will see. Performance, processing and performance. So based, see, the performance is going to depend on all these three topics. So what is the history of manufacturing? It starts from 300 BC or so, and it goes on one by one, and today's number of activities have been die casting, lost gas process, ceramic casting, all will be coming. So one example is production of cement by die process is one example of powder metallurgy manufacturing of cement. You see how it comes. See, the very best way to enjoy powder metallurgy based manufacturing is one's kitchen. Particularly my area of research, now with what I am working is how through powder metallurgy can I make sheets, can I make plates is what the basic idea. See, the sheets and plates are meant for its ductility, but powder metallurgy components are brittle in nature. So, can I balance between this brittleness and ductility so that the sheet or plate can be balanced? Balanced. It will be neither brittle nor completely ductile. And where I can apply that? This is what the question, the $1 million question is running around the industry. See, why? Because titanium has certain properties. Right, aluminium has certain properties. I can't, in solid state, I can't mix both and I can't make the benefit out of it. The only way I can make benefit out of metals or materials or alloys is I make powder mixture. The best component is making mixture. In mixture, you will get all items, crispy item, non-crispy items, salty items, sugar items, sweet items. Everything will be mixed and then it is called mixture. So it gives a unique flavor. The same way, metal, titanium, aluminium, cost is less of aluminium. Titanium is costly. Stiffness is very less in aluminium. Stiffness is very high in magnesium or titanium. So can I balance between the cost and material and its properties, its performance, its structure? Then this, if this $1 million question could be answered for one delta X or one line answer that I could move forward, that is one of the beautiful answer to this society. If a set of people come forward, I will be one of the happiest person in this particular area. That is the uniqueness of powder metallurgy. Yeah, it has its own limitation. Any process has its own limitation. You have to see the application and select your options. Right. You see, the steel powder is one best example for powder metallurgy component. Maybe the size of the powder is somehow different. Size of the powder is somehow different. See, the biscuit is one beautiful example for powder metallurgy component. It is a powder compressed and then sintered. That's it. First green compaction with PARLEG and then it is going into the oven to get sintered and it comes out as a very nice product. Industry, eating industry. Whereas in engineering industry, how I can do all these things. Right, that is what the beauty of lecture. So anywhere, everywhere you could see these steels, powders and all will be going and coming inside. Right. Every industry uses lot of powder metallurgy components. People may think where these components are used. I will show you in my upcoming slides. Lot of components are used. Lot of components are used. Right. What is this? This is your another film industry. This is another very beautiful example you might be how this component could have been manufactured. Just to give a thought process, the very turning point scene of the movie you could enjoy. Or else watch lot of English movies. So many powder metallurgy components. How that could be manufactured? What is the purpose of application? If that is could be answered by this set of people around 30 or 40 who are listening to my lecture. And if you start your thought in that, it will be a wonderful outcome of this lecture. Right. Any manufacturing process, I process this way. I can shape. I want to enhance the property. Can surface the process the surface. Whereas shaping this particulate processing this particular area is what our area of interest. And I give input as powder, and I want output in this form of sheet. Example, which now to be more, and if they are sheets and it should be processed. See, titanium stiffness ratio is high, magnesium stiffness ratio is high. If you roll like this, it won't come out as a sheet. Either hot rolling or cold rolling sheet, it is very difficult to get the sheet, and the structure is different, its performance is different. Hence, how can I process this? And one more big advantage of this powder metallurgy is near net shape forming. In one single shot I can form it. So I want to process the particles, I want to process the powder into a sheet. If that I could do it. So this is normally we have top down approach and bottom up approach, right? I'm going to go by what? Bottom up approach. So we will take atom level, molecular levels. That's what lot of ball mills will be there. You can make nano powders of n number of metals or alloys, and then mixing is another parameter. The size of the powder is another all can be controlled, all can be controlled, right? If you purchase the wheat flour for making your chapati, different companies give different size of the powder size. So based on that, the taste of the recipe change. Similarly, if you change here, if you change here this size of this ball, powder size, nano, your of the component is different. You join clusters, then nanoparticles, then make it powder, and then bulk it. See, we start with here actually. Still, you can come from down also, and you can make this powder. Lot of research is going on in all these areas, all these areas. And this powder, when combined, you will get it into a bulk component or a sheet component, whatsoever it is, and it has totally a different set of properties which neither material powder, the powder may be a combination of 1, 2, 3, 4 alloys. You will get totally a unique one. You will get totally a unique one. See, all these are beautiful examples of various mixture mixed. Actually, it is casting. See, if it is taken to liquid stage and then poured, it is casting. If the same powder, if it is in powder form and then compacted and sintered, it becomes metallurgy. So these are all very beautiful examples. You could see that of, see, that's what I'm saying. This is that of casting, where you melt and flow. Whereas in powder metallurgy, you use what? The that powder form. Yes. Science of producing metal powders. See, normally audience will not be interested to see running notes. First came. And now comes the real concept. So now you have what is powder metallurgy? You make metal powders. You take any metal alloy, whatever it is, you crush it, put it in ball mill. The size you can change it. So finish semi from mixed alloyed. Yes. Am I audible? Hello. Hello. Am I audible?
Yes, sir, you are audible.
Right. Okay. From mixed or alloyed powders with or without the addition of non-metallic constituencies. See, you can mix other materials, nanomaterials, lot of whatever is of your interest, provided you know the properties of each individual and then club it, you are going to get something near in that area only. Overall change may not take place. Maybe slight changes will take for the improvement of properties, structure, and process. Because of all these three, my performance increases. Always keep in mind the tetrahedron. The tetrahedron, materials engineers tetrahedron. My ultimate aim is performance of the component in its given situation, in its given environment, in the given time. So for this, now I am going to adjust the other three: structure, processing, is one of the very toughest part. You can't balance everything to get the best combination out. It is one of the very toughest part. I too understand, agree with you. Right. So raw materials or powders can be pure elements or pre-alloyed powders, and then how you make powders by automation or else reduction of components or else electrolysis. Various way you can make powders. Normally it is made with automation, and this automation also the size of the distance of the nozzles and all will play major role. It is, see, I was given 60 minutes for this. In 60 minutes I can give a spark. If any of the speaker is interested, we can start a collaborative research. It's an open offer. If any student research scholar is interested to pursue his research in this area, do approach me. I have a UGC project AICT project which we are working. You will be a part of that and you can perform, you can PhD degree, right? Any doubts later on this particular topic, right? Okay, powders along with additives or mixed with mixtures. You can use lubricants, and you can then see lot of research papers you could see on this last line. Size, people have fixed the windows. They have optimized on size, optimized on flow, density, and compression. All these things they have did it. Lot of work has been presented in the open literature. How to make powder and then how to compact it. What are the various process parameters involved? How can I optimize it for this particular application? Lot of research papers. This is a very good old technique, very old technique. Hence, it is difficult to set the problem in this area. But still, if once you start enjoying, you can, sky is the limit. So, after making powders, what I will do? After making powders, then I have to go for compaction. What type of compaction I will do? What type of, you can go for green compaction or hot compaction. Green means you don't heat it or put it into a furnace. You better compaction is performed using dies machined to close tolerances. Dies are on those dies, and that is another area to work. The basic purpose of compaction is to obtain a green compact with sufficient strength to withstand further handling operations. I will show you some of the very beautiful uh, food items that could be taken around this Indian continent, Indian subcontinent. Okay, so this is first I compact it, maybe a hot, see, HIP, hot isostatic pressing, that's what, by hip, and or else pressing from all sides, pressing from one direction, pressing from two direction, uniaxial pressing, biaxial pressing, triaxial pressing, the die and the component in the same temperature pressing, that is hot isostatic pressing. So you have lot of variants in that. Every component will influence the performance of the product. Okay, so that's what research is. Then sintering. So after that you take it to a controlled atmosphere to make the bond atoms metallurgy. So far, by compacting, you are mechanically binding. You are mechanically binding. You can touch and see, but if you apply some force, it loses the bond and it comes as individual molecule or individual powder particle. But once you take it to sintering, the atom starts combining metallurgically. Bonding occurs by diffusion of atoms done by 70% of absolute melting point of 100% means that 100 degrees centigrade means at 70 degrees centigrade this diffusion takes place. It serves to consolidate the mechanically bonded powders into a coherent body having desired on-surface behavior. So then densification is also an important, how better you compact it, so that the molecules get compacted very nicely. And then in what type of furnace you make it, what is the protective atmosphere? Nitrogen is one that is usually used. In nitrogen atmosphere, we normally maintain the furnaces for sintering so that densification will be good. Right. This is one beautiful example, right? How he has compacted. You see, this is only sintered, no? We can't eat. It is only compacted. It is only what? Compacted. This is one Kerala type food called puttu, where the molecules or powder is, you can see this. This is what the powder loose it will be. But when it is served, it will be in this form. But you see how differently this may be if at all I see this with an engineering view, this could be one material, and here also I can give variations. Here also I can give variation. See here, the grain size is different. The grain size is different. Right. So this way we can conduct lot of experiments with alloy powders and all. Right. This is very typical an Andhra powder. Right. You see how different we see these kind of what in between in a concrete. Concrete is a beautiful powder metallurgy concept. Making of concrete, it has a cement in granules and then different sand. So three different types of powders are mixed. Similarly, you can see over here. Concrete is one old technology that makes use of powder metallurgy concept, and just assume this trend. That is in civil engineering. We want to explore something in what mechanical engineering, right? In mechanical engineering, but that very good in compressive. Concrete is having very strong strength in compression, right? So that we want, if I could use powder metallurgy and get a sheet which is good in ductile performance, then it will be a service to this society. Right. This is another beautiful example for making powder metallurgy concepts. And see, that's what I say. It's all what we observe and how we introduce this idea into our engineering field. So how you make all these will be made by this methodology only. You atomize. These are all how to make various methods to make powders. You atomize, you reduce, you electronically deposit into mechanical alloying whatsoever. See, mechanical alloying, concrete is mechanical alloying. Same you can do for other powders also. Metal powders, you control the size of this, you control the size of all these particles, and then you add lubricants, because dye, when you are compressing it, compacting it, friction between the powder and the dye will create lot of interesting facts. Right, so that's why you use additives and lubricants. You blend it. Blending is one of the best part of how better the different components of powders mix. Blending, the best example I could say is you just make blend and blend and blend. That's it. Then you can go for what? Cold extrusion, injection molding. All these are done at room temperature. Right. Then next is hot compaction. If you do cold compaction, only sintering is required. Whether you want to do in atmospheric environment or vacuum environment, controlled environment. And once the component is ready, it comes out as secondary and finishing operations. Right. So this is how I make. So powder compaction methods, you have different methods. Double action pressing, isostatic pressing, powder rolling, stepwise pressing, powder extrusion, powder swaging, explosive compacting, and powder forging. So this is how I compact die compaction. You can go through this later. How I compact it. I keep the start of the pressing cycle. I allow and fill the die. It is empty. I will fill the die with powder. This powder may be a mixture or single one. The size of that is different. And then this comes down and starts pressing. Compaction is completed. Part is ejected. This is unidirectional compaction. This is unidirectional compaction. You have bidirectional. This is another example of unidirectional compaction. Right? You have bidirectional compaction also. From top and bottom, you can compact. You see, whatever shape you want, you can get it compacted. That's the beauty. That's why it's called as near net shape forming. Near net shape forming. You just compact it and get it in what form you want. Some bushes right? Green tools, the what is in lathe machines we have a single point cutting tool, and in that single point cutting tool we have inserts. Those inserts are processed through powder metallurgy route. One of the it shears the material something like anything, either MS or steel or whatever it is, a very small piece of insert which is routed through powder metallurgy will shear that component. So that's the power of powder metallurgy, one should understand. Right. These are all some examples of components which have been manufactured through powder metallurgy. You see this. This we might have seen at several places. Right. Ceramic components, ceramic is a beautiful material that has to be done through this way only. There are no other way. The best part is every day we brush, every day we go for restrooms and a lot many restrooms, and within different shapes the ceramics are molded and you got it. Lot many component products are processed through powder metallurgy. So you have, see, this particular component which is shown in the figure is an example of unidirectional compaction. Unidirectional compaction. Right, all are examples of unidirectional compactions, and every stage we have to take care of. Hot isostatic, hydrostatic compaction or isostatic compaction. Right, powder is placed in a flexible mold and immersed into a pressure vessel and compacted using hydrostatic pressure. The method is flexible with particle size and shape. The final global stresses are isostatic. Iso means almost equal, almost static around the compacts. Production rate is low. That's everywhere we have advantages and limitations. We have to see for the performance of the product in the set situation. Right. You have triaxial compaction also. So that sigma 1, sigma 2, sigma 3, all stresses, principal stresses will be controlled with single on a same moment of time. Setup is similar to fixed mold isostatic pressure. Lateral pressure is given and axial pressure can be controlled separately. Shear stress within the compacts, enhance green density and strength. Torsional shear stress is applied. Minor principal stress is uniform in all directions. See, there is a wonderful book, I have kept it in reference. The powder plasticity through powder metallurgy. See, it is any component we will have in our brains that any component that is made through powder metallurgy route will be brittle. But there is a separate book devoted for plasticity through powder metallurgy. So that you go through, you could enjoy that book. So you can even vary the density variation in compacting. That is one. See, this part may require more density, and this may require more density. So that way also I can manufacture. I press here more, and I press here less. So naturally, the density variation of the part is also different. Okay, so this is one of the best advantage of powder metallurgy. Whatever you want, you can do. Only thing is cost involved in creating this initial setup is heavy and hefty. Right, compaction of metal powders by cold isostatic pressing. Metal powders is placed in a flexible rubber mold made of neophron rubber urethane polyvinyl chloride. The assembly is then pressurized hydrostatically in a chamber by water. 400 megapascal pressure is maintained, and you can pressure. You see, the mold which is inside the powder, green color powder, is being what? Applied pressure is applied from all sides so that a hollow tube will come out with no stresses, residual stresses. If you make it through extrusion, if you make it through rolling or tube forming, lot of residual stresses will be there, right? Absolutely residual stresses will be eliminated if I start compressing a powder like this. So this is one way. So this is another example of cold isostatic pressing. Right. So what are die insert and liner? We have different problems over here. What is die wall friction? Particularly this happens in uniaxial load, makes the powder to deform and spread laterally. This lateral pressure is against the tooling and creates a friction, wall friction. Wall friction reduces powder flow and sliding during compaction. Continual pressure loss with the distance from punch as the power bleeds off. There is, see, you may see that the friction is only at the wall, but it affects the complete product. In particularly in the powder metallurgy, the complete product get disturbed because of this die wall friction. That's the reason we go for what? Lubrication. What type of lubrication helps? What? Molybdenum disulfate, or else any mixed with other powders also you can use. This is what my area of interest is. How I roll, how I compact, and how I want to make a sheet like this. And on this sheet, if see, the question is very clear. Um, the question is very clear, right? So now it comes over here. You roll and make a sheet, and by normal rolling, and then you put powder and get and roll a sheet. Is it possible to make this second sheet more stronger than first sheet? If that could be done, it is a patent. Right. So powder is, this is how powder is fed through a roll gap in a 2 high and is compact into a continuous strip of 0.5 meters per second. Rolling process is carried out at room or elevated temperature. So how we do this and how we get this? See, a very a beautiful titan. See, why this fellow has not rolled the titanium strip in normal rolling. Instead, he has used a powder metallurgy. He has processed this through powder metallurgy, because if you roll titanium strip, it won't get rolled. Instead, it comes out as chips of the roll. It chips off the roll, it gets adheres to the roll, and only you can take chips. You can't continuously on the way. Okay, so that's how we have to do. Right. Next is, so this is injection. By injection molding also we can do this process. You see how your pan, what is that you use in your non-stick containers, no? How such kind of things are used. After sintering, preformed PM parts may be reheated and then forged in a closed die to take the final shape. You should see that. Then sinter forging. This is one beautiful case where you heat and forge at same point. This is what called as sinter forging. Right. Then no sintering stage is involved. This is powder sinter forging. No separate sintering forge is involved. Loose powders are compacted and then hot forged. This is called sinter forging. These are some of the advantages of sinter forging. Right, cold isostatic pressing. So you can go through lot of cold wet bag process, fixed mold process, and applications. This is normally we do, and this is the one we are trying to do. You want to prepare a green strip and then cold sinter. We don't want to go for sintering, then densification of the sintered strip, and final cold rolling and annealing. Thank you. These are some of the, this is some of the references. These are some of the references. So I'm open for questions. I'm open for questions.
Any questions from the participants end?
Hello.
Yeah, please go ahead.
Good afternoon, sir. Thank you so much for your beautiful session. Actually, I have done a few projects using powder metallurgy, aluminum silicon carbide composites per gear. So I am finding it too difficult. Hello.
Please go ahead. I'm listening.
Yes, sir.
Yeah. Actually, I'm finding it difficult to publish the work because I have found few journals in Elsevier, but I couldn't find it. Like I have submitted, but they were rejected. So,
Hmm.
can you able to suggest some good articles to
Hmm.
publish the work?
You just shoot me a mail to this particular. Have you seen my what is this email ID, sir?
No, sir, it is not there.
Can you able to see now?
Yes, sir. Yes, sir.
You just shoot an email ID. We will work together. Let
Okay,
us
sir.
work together. Right.
Yeah, sir. Thank you, sir.
Your good name, sir.
Sir, my name is Ruben.
What, sir?
Ruben. Ruben.
Fine, fine. Please, 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 please.
Yes, sir.
Madam, any next candidate?
Yes, sir. I'm just waiting, sir. Any other questions? Yes, ma'am. Yes, sir. Somebody just raised the hand. Yes, sir.
Neelakanta Mahalingaya, please ask.
Yes, sir.
Please ask.
So you can ask the question, sir.
Yeah, good afternoon, sir.
Good afternoon. Please go ahead, please.
Sir, regarding this powder metallurgy, can I have a question? Like, you are giving good example of chapati and all. So you can take an example of aloo parota, like same that we
Fine,
can
fine.
put the stuffs inside the metal, then we can go for processing. Powder, we can put it inside the metal, then we can go for processing. Is it possible in such a way?
We have to try, sir. We have to try. We can try.
Because now the great important challenge is the processing.
Yes,
So,
exactly. No, that's the reason. Through this
yeah.
route, is it possible? We have to explore.
So we can mix up the powder and metal
Yeah.
together, where one is a
The
required
entire
density
world
stuffs.
of metal matrix composite is a part of powder metallurgy.
Yeah.
Yeah.
So in this regard, we have any development now going on, sir?
It's happening. It's happening. It's happening.
Okay. Thank you, sir. Thank you.
Thank you.
Any more questions from the participants' end?
Fine, madam.
Okay, sir. So thank you so much, sir, for giving us a valuable information about the latest what you have submitted. And thank you for sharing all the information. And out of your busy schedule, you have given this opportunity. Thank you once again.
Thank
Thank you
you.
once again, sir, on
Very
behalf
kind
of
of,
management.
very kind of